In this video, let us learn to calculate the rigidity modulus of the material of the suspension wire of torsional pendulum by graphical method. We have already done this by calculation method in one of my previous videos. Now we will do the same by drawing a graph. So this is the readings or the observation taken during the experiment. In the first column, we have the length of the pendulum L. Then we have time taken for 10 oscillation. Okay, for the length of 40, the time taken for trial 1 and trial 2 are 41 and 41. So we have mean as 41. For 50, the time taken for trial 1 and trial 2 is 46 and 46. So our mean is 46. So this mean of trial 1 and trial 2 will give the time taken for 10 oscillations. For example, for 80, for the length of the pendulum to be 80, the time taken for both the trials are 57 and 58 respectively. So the mean comes up to be 57.5. So the time period T is nothing but it is the time taken for one oscillation. So we have the time taken for 10 oscillation. When we divide it by 10, we will get the time period. For the length of the 40, it is 4.1. So that is 41 is divided by 10. So we get 4.1. For the length of the pendulum 50, the time period is 4.6. So then we are squaring it. When you square, we will get T square. So square of 4.1 for L40, it gives us 16.81. When you square 4.6, it gives 21.16. When you square 4.95, you get 24.50 for 60. Here we are going to draw the graph between L and T square. So I have taken the values of L and T square separately and tabulated. For the length of L40, the T square is 16.81. For 50, it is 21.16. For 60, 24.50. For 70, it is 28.09. For 80, 33.06. Okay. Next, take a graph sheet like this and split that graph sheet into two coordinates. So, x and y axis. Take the length of the pendulum L along the x-axis and the T square along the y-axis. Then we need to choose an appropriate scale. So on the x-axis for our readings, I have taken on the x-axis 1 centimeter is 10 centimeters, that is 10 into 10 power minus 2 meters. And on the y-axis 1 centimeter is, that is T square is 2 seconds square. So we have taken the appropriate graph and we have plotted these scale values along x-axis and y-axis. Look at the values along the x-axis, that is the length of the pendulum. They are marked as 30, 40, 50, 60, 70 and 90. And along the y-axis we could see 14, 16, 18, 20. So 1 centimeter is around 2 seconds square. So we have plotted till 34. So it is not necessary we should start from 10, 20 and 2, 4, 6. So we can start according to our readings. So my beginning reading is only 40 centimeters. So I have started from 30, 50. So with the L values of L and T square, let us plot those values. So for a L of 40 centimeters, the T square value is, I think it is 16.41. So I have plotted here. So we could see all the 5 points lying on a same straight line. Then with the help of a scale, join all these points. There may be 1 or 2 deviations. Let's not bother about it. Just join the maximum points falling on the straight line. So even you could see one point, that is for the length of 70 centimeter, the t square is deviating from the straight line. Let's not bother about it. You just connect the maximum points falling on that straight line. Then we need to take a slope for this. So you need to take slope like this. Don't ever take a slope on the points we have already marked. You have to take a slope on points other than we have already plotted. So a slope is drawn like this. Then find out the slope values or the intercepts on x-axis and y-axis. Generally we know what is the slope. The slope is nothing but it is dy by dx. So here what we have is, we have t square along dy and L along dx. So in formula we need L by t square. So L by t square, if you want L by t square means, then it is 1 by slope. So 1 by slope means dx by dy. So on the x-axis it is dx is 75 minus 44 into 10 power minus 2, and on the dy y-axis it is 30.6 minus 18. So simplifying this, we get 31 into 10 power minus 2 divided by 12.6. So we got L by t square as 2.460 into 10 power minus 2 meter per second square. So we have found L by t square from the graph. So with this L by t square, we can calculate eta, the rigidity modulus of the material of the bar. So from the graph, L by t square value is 2.460 into 10 power minus 2 meter per second square, and the value of A, the radius of the wire is 0.4075 into 10 power minus 3 meters, which is already mentioned in the video by calculation method. Then when you do A power 4, you get 0.0275 into 10 power minus 12 m. The formula to calculate the rigidity modulus is eta is equal to 8 pi I by A power 4 into L by t square. Already we have calculated what is the value of I, that is the moment of inertia of the circular disc used in the torsional pendulum. So A into 3.14 into 2.306 into 10 power minus 3 divided by 0.0275 into 10 power minus 12, and the L by t square value is 2.460 into 10 power minus 2 m. Then separate all the numbers and powers separately. Then we get 8 into 3.14 into 2.306 into 2.460, and separating all the powers will give you 10 power minus 3 into 10 power minus 2, and the 10 power minus 12 in the denominator goes to the numerator as 10 power plus 12. The whole thing is divided by 0.0275. Then multiply all the numbers, we get 142.4997312, and add up all the powers, we get 10 power minus 3 minus 2 plus 12. The whole thing divided by 0.0275. When we divide, we get 5181.8 into 10 power 7, that is minus 5 plus 12 power will give us 10 power 7. Then push the powers, take the powers outside, so we get 5.181 into 10 power 10 Newton per meter square. Generally we write rigidity modulus in terms of 10 power 10. To bring the powers in terms of 10 power 10, we have taken 3 powers outside, so our eta value becomes 5.181 into 10 power 10 Newton per meter square. So we have found the rigidity modulus of the suspension material of the suspension wire of the torsional pendulum. In the previous, we have already calculated by the theoretical method or the calculation method, which we got it as 5.095 into 10 power 10 Newton per meter square. Here we have done the same by graphical method and obtained the result eta is equal to 5.181 into 10 power 10. So when we compare the values obtained by both the methods, by calculation and graphical method, we could see both the answers are almost close. So which says we have done the experiment in a correct way.